Yeah, good morning. My name is Henning. I'm managing the customer success team for industry for Unity. I have the honor to introduce our dear customer TomTom to you. And today we talk about navigation of the future using gaming techniques for automotive maps. I give a quick introduction to you in the industry before I hand it over. And as you might know, or some of you have witnessed our industry booth already, so Unity has quite a footprint in industry since a couple of years, addressing use cases around simulation, virtual training, stores, customer experience like configurators, and so on. So we classify our use cases mostly into these four scenarios, which is immersive 3D collaboration. You know everything about collaborating around the product, the typical design review process, complex products like a car, for example. Virtual reality technologies used since a couple of years to bring designers, engineers together to collaborate around a virtual car. Immersive trainings, really good use case for virtual reality and the usage of 3D. It adds a lot of value for people to be trained in a virtual environment, so that makes complete sense to a lot of people and are using it. Immersive custom experience, like said, car makers are using VR and real-time 3D technology to sell their cars, which is a complex product, but also others like Oma Piguet, a luxury watch brand, is using Unity to create immersive representations of their watches to have a more customer-oriented customer journey with them. And last but not least, embedded systems, which is all about embedded systems. And what we talk about today, HMI, car, map rendering service, and so on, falls into that cluster. So happy to talk more about this. Our footprint in specifically the car HMI field has increased dramatically since the last couple of years. We have more than 30 global car brands working with Unity already, with more than 50 models actually on the street already using Unity in the cars today. And usually it starts with the car is the star, also in the HMI. So people using 3D engine to visualize the car you're actually sitting in your HMI. And then they start to think, okay, oh, what can we do now? So they add more weather effects and that kind of things. Then they're also used to start 3D engines to visualize other things of car, like in that case, charging of the battery, but also instrument cluster and so on. So I cannot share like all the things with you our customers are doing at the moment, but wait for it. A lot of customers and a lot of new cars will get on the street end of this year, and next year you can see and witness Unity in action. And then other companies are using it already a bit more progressively. Here in that car, Motors is using Unity to visualize these procedurally created flowers. And in kind of former HMI tools, it was not possible to do these kind of things. You had videos, of course, to have like a relax mode in the car and so on, but have truly something procedurally created like this, which interacts to touch at the moment where you touch the screen, but it could also interact with music, with external sensor inputs and so on. So that is really important to run on a real-time engine, and in that case, on Unity. So these are the biggest challenges or drivers we face in the industry. One is there are still performance constraints. As you know, a car is not a supercomputer, it's not a high-end GPU, it's not a PlayStation 5, so we still have to deal with, I would say not low-end GPUs and CPUs, but more kind of the mobile segment where Unity is, as you know, pretty strong at. Then time to market, it is like, even today at most car makers, you still have this engineer and design department duality, and they need to work together on one tool, which is not happening today. So there's a long cycle of development process for HMI. So the promise working with a tool like a game engine or Unity in that case helps to improve the development process by bringing designers and engineers together on one tool. And last but not least, an underdeveloped ecosystem, not only in terms of lack of developers. So today tools in the HMI space are very niche products sometimes. You don't find a lot of users for them. And a tool like Unity can provide you access to like literally millions of potential game developers, artists, and so on to work on your project. But also you have a tool which has an ecosystem of potential agencies, game studios, and other companies already out there which could build experiences for your car platform in the future. And talking about ecosystem, I want to hand over to TomTom as one of the biggest providers for map solutions for the automotive industry. And welcome, Rock and team.
The air was sharp with the promise of the oncoming winter, every breath a reminder of the switching seasons. And the tree leaves creating a tapestry of colors, some still clinging to the trees, some gently falling through the wind, others decorating the streets below in amber, gold, and brown. And as I made my way through the cobblestone paved streets of Ljubljana that fall morning, I looked up, seeing the sun shining through the trees slowly and baking the whole area in the soft glow. And it's the kind of memory that stays with you, like that stillness of the morning, quietness of the street. But it really was something that would remind me forever about this morning that came right after. As I walked through the street, through the door of my office at the time, my manager was already waiting. My then manager was already waiting for me and, "Come with me, we need to talk." So we stepped into the office, one of the meeting rooms, and he presented the case that the customer just dropped on us. And we are in the 90s. There is no PowerPoint practically. He's using papers to show me what's it all about. And the customer is demanding, we need to present within 3 days visualization of satellite, aerial imagery that they had, which for the time, this was a very large data set. We are talking about CD worth of data. It sounds silly today, but remember, this is the PCs of 90s where 16 megabytes was a lot of RAM, and single image on that disk was 30 megs or more. So an interesting problem, and it all had to run on Windows 3.11, 16-bit. None of that advanced stuff yet. So I stepped into the office talking to the senior engineer who's already looked at the problem, and he's briefing me on what he's already tried, what didn't work. Well, nothing worked yet. Remember, we're talking Windows 3.11. There are no tools here. You don't get a library that does any of the codecs for you. The OS basically does nothing other than file system handling. So it was all done from scratch. He looked at some libraries, found one that actually compiled under Windows for TIFF parsing, but he couldn't get it to read any of the files that we were tasked to use. We are talking GeoTIFF here, which is encoded actually as a series of JPEG macro blocks inside. This is something I discovered a little later when I dug deep into the format. So, okay. But he's only worked in this company for about 5 years. He's senior. What does he know? I'm still in school. I can do anything. I was, in my early 20s. I could change the world. I'll figure this out. So I spent about, 10, 12 hours digging into the alternatives to the library that he rejected. And I realized that even with all of my optimism at the time, that was not going to be something that will take me days, because rewriting a JPEG decoder, even just the block decoder from scratch, we are talking months probably for what I knew about those type of codecs at the time. And even just taking an existing JPEG library and trying to funnel it in. This wasn't just a simple case of passing the bit stream down to the JPEG and let it do the work. No, you would have to extract the macro blocks, feed them into, it would require low-level tackling with the library. So, okay. I was back to the square one. Let's try that libtiff again. Maybe I can make it work. Few more hours of debugging. The lucky part about this was the 90s, so energy drinks and Diet Coke made the day. So sleep was an optional luxury. We didn't really need it for a couple of days usually. Eventually, I stumbled on the answer already was looking at me the whole time. 16-bit Windows. The library was built around expecting 32-bit CPUs. We are in the 90s, after all. There was very, very few pure 16-bit CPUs left. And some of the handling of the especially pointed arithmetics was not anticipating that problem. Looking at the code, I found a few spots that were possible to change without having to re-engineer large swaths of the library. Managed to compile it, feed it into a direct draw surface after it decoded something, and we're off to the races. We have something. To be fair, this was not the first image I saw. The first one had reversed RGBs, but history will not remember that. But yeah, okay, job's done, right? We have images there, we can load them. But wait, did I say direct draw? I mean, we can move it, right? We can animate it. Sure, it's, again, sounds silly by the modern standards, but back then, smoothly animating this kind of data sizes was just not something you'd see, especially not in Windows 3.11. So I added this little bit of functionality, panning the map, making it look like you're flying, showed it to the management. Everybody was like super hyped up. My manager decided to just cancel the probation and all my onboarding tasks. Now, you're done, we're good to go. Customer was very happy as well, and like the rest is history. Except, I mean, this was my first job, and I didn't stay there that long. So within 12 months or so, I would be off to very different future, where I went to my first trip to Japan, which led to 20 years in game industry. But that's a story for another day. Today, we're not talking about that part of my history. What I didn't know is that 20-something years later, I would come back to the maps in a very unexpected ways. Now, before I go there, tell me if anybody in the audience knows what this is, or maybe you have used one of these, or at least seen one. Okay, we have a few people that know them, yeah. So for those that don't know, this is one of the first portable personal navigation devices. TomTom introduced them to the world pretty much as the first leading company in that space. And this is before the phones existed, so yeah, it was the only way you could have a portable navigation in your hand or in your car. Hardware aside, the interesting bit is, of course, how did this all work with navigating and rendering the maps. And back then, this was all a CPU-driven system, so everything you see is software-driven. There was no accelerated hardware in there. So it looked suitably primitive, but if you remember games 10 years before, it was kind of similar. So this is a very, very familiar evolution to those of us that were there. But yeah, this is the start in the early 00s, and then over time, the maps evolved with the hardware, of course. So slowly we started getting graphics acceleration towards the late zeros and early teens. We started getting more features in terms of like the 3D elements that you can put on the map. But this is still software stacks that are highly optimized for the use case. They're built for a very specific purpose. It's not some general purpose rendering. You just want to put these vectors on the map, sometimes maybe a 3D texture, but it's not a real engine in that sense yet. It's a map engine. And as the evolution continued, we get to the late teens where, this is the modern look of the maps that everybody is familiar with today, like what Google and the likes commonly look like. And at this point, we start seeing the fidelity is increasing. We start to get more and more also 3D elements that look familiar to the modern accelerated visuals. But also, creating these visuals start to become more and more driven by the cost of authoring this data. Like, how do you make the look of the map styled to the right purpose, like whether it's for browsing, driving, or something else? And it's like in games, content creation starts to become the bottleneck more so than the underlying technologies. And especially when the underlying technology is very custom and proprietary. And this is around the time when I joined TomTom as well, 3 years ago, when we started looking at what the future of the mapping might look like. And the experimentation started into, of course, game engines. So our researchers and designers were playing around with Unity, seeing what they could do. And of course, none of this is meant to be a real representation yet. It's just experimenting, how quickly can a designer whip up something interesting? And is this something we could actually use in a real like navigation case? We start exploring all kinds of different concepts, from different visual styles to all this stuff that a modern engine can actually provide you with a fairly easy fingertip access of your tools, but also are these different styles something you could use in different contexts? It's not just one size fits all. And from all that experimentation, we came up with the 3 pillars of what we believed a market-leading visualization experience for maps would look like. So I'm not going to read the details here. The pillars are around fidelity, the productivity pipeline that I mentioned already, and delighting the end users. The productivity fits very nicely with what Henning mentioned at the beginning as well, right? These tools allow us to work a lot faster, to empower designers in ways that just hasn't been possible with the proprietary stacks. And you have these what you see is what you get workflows that are just irreplaceable. I mean, Unity is in a class of its own when it comes to iteration speeds, and this really makes a difference with these kind of engines. Fidelity is just, the rendering quality. You push it as high as the hardware allows, but the engine, again, allows it. And delighting the users is really all about the use cases. What is important, and to actually make it a functional use case, but also leveraging the quality that these new visuals bring. And we will talk a lot more about that in this later part of the presentation with Arnaud and Piotr. But with these pillars, we had an idea where we wanted to go, so we made a quick prototype. This was a small team of 4 people that spent a couple of months working on something that we showed at CES. And the key thing about this demo is this is not your usual put a bunch of assets inside of Unity and visualize them. No, this is running off of our actual online services. So all the data you see here is a real map. None of this has been custom tailored for the demo purposes. It's already rendering a combination of actual vector rendering that was custom built for this. It doesn't come with the engine. And yeah, it runs all online. It's all real. So none of this data is pre-installed on the device. Of course, it also runs some of the navigation features, like the routing already, for real. The key of this demo was to get a bit of a reception, make a statement about what we think, but also to see what how the customers respond. And the response was overwhelmingly positive. We got a lot of validation of the 3 pillars that we established based on the feedback. So that led us to feel strongly that this is a part to go in towards product development. But before we went there, of course, we had to pick a technology. And these are our reasons for why Unity made a lot of sense. It still hinges strongly on the same pillars, but with the addition of the cross-platform being a big part of it, because we do need many platforms for our products. It's not just running on one. And with that said, that brings us to, we had our phase 1 completed. We had a product strategy, a pitch, and a product name. We picked a technology, we did a technology review, and that brings us to the development. And the question mark is something I will let Piotr talk about more.
Thanks, Arnaud. Hello, Unite. My name is Piotr. I'm a software engineer on the team that works on TomTom's rendering solution developed in Unity. I'd like to show you the technical side of the challenges that we are dealing with when developing software for the automotive industry, and some of the solutions that we transplanted straight from the world of game development into our map rendering. First, let's have a look at what the hardware and software that our products run in may look like. This is a high-level overview, a slice of the automotive stack. The hardware at the bottom, sometimes only as powerful as a mid-range phone, a layer of virtualization on top of that, mostly for security purposes so that none of the operating systems mess directly with the hardware. And then inside that virtual machine, several operating systems running in parallel at the same time. Some of them are real-time operating systems, meaning they take priority over the regular ones. Now, this is not exactly the complexity that we have to deal with directly, since we only run within one of those regular operating systems. But it is impacting our work in a lot of ways. Most importantly, we only ever get a portion of the device to work with. And so we have strict limits on memory and CPU usage. And this is the kind of complexity that we do have to deal with. This is what an infotainment system may look like in a modern vehicle. A single chipset running our software and 5 displays connected to it. Each of them may have different parameters. Each may be showing a different portion of the map using a different visual properties. We may have to share the screens with other applications and support different interactions in each of these screens. Another part of complexity that we have to handle is the software stack in each of these operating systems that we are supporting. What my team is working on is a Unity plugin at the very bottom of this stack. In case of Android, we wrap it in an application that we build as a library so that it can be then used in our Android SDK, which is one of the products that TomTom offers. When built for Android, it gets a Java interface, which we use for starting it up, shutting it down, and some operations where time is critical. But for transferring large amounts of data or complex data structures, we have a side channel based on gRPC, which the SDK uses to communicate with that library. That SDK is then used in an Android application published to automotive customers or available publicly on our developer portal. If run in automotive, it is then handled by another layer, sometimes something called a composer, which assigns displays or portions of displays that we can use to render the map. Now let's have a look at what it takes to render a map. I recall some 20-odd years ago, when I was playing in Morrowind for the first time, they promised that one could traverse the entire world from one end to another with no loading screens. Now, my PC with Riva TNT2 and 256 megs of RAM didn't quite deliver on that promise, but the technology has advanced since then, and so has game design. And what we have to deal with when rendering a map is a similar problem. We have a single level, which is the whole world. We show it at different levels of detail, which we call zoom levels, because they correspond to how far the camera appears to be from the map. And we split the world into smaller chunks we call tiles, so that all of that is more manageable. The tiles contain the data about the map in a vector format. At the highest level of detail, we have 2 to the 44th tiles. Well, we don't have to show all of them at once, but we need to be ready to show any subset of collocated tiles at any given time. And the big differentiator, something that Rock has already mentioned, is that these are not local assets packaged with the application. All of this is online, and our plugin has to download them, parse them, process them, generate meshes, generate all the visual properties, and then render them on the screen. This is what this rendering looks like in practice. On the right side, in the game view, you see the map rendered as it should be. On the left side, in the scene view, you can see how the tiles are being loaded in and unloaded as we manipulate the map. We zoom out, we download and display tiles from lower zoom levels. We zoom in, we need to draw a different subset of tiles. We cache some of them, but when we move the map to a new area, we need to download a new set of tiles. In the hierarchy view, you can see elements popping in and out. Those are 3D models of buildings that you can now see in both views that we call landmarks. These are actual 3D models, the only kind of data that is not vector that we have to download and display in our map. Now on to the other piece of this puzzle, knowing how to interpret and the data and what visual properties to apply. For that, we store this information in what we call a style that adheres to an open specification that we later extend to add custom Unity properties such as the lightning, the Unity materials, or the skybox. The style consists of a number of elements, the most important of which for now are sources, which tell us where to get the data from, and layers, which define how to interpret the data and what visual properties to apply. For instance, we may have a source with a list of points and 2 layers referring to it, one telling us to draw an icon at each of these locations, another one telling us to draw a circle at each of these locations. Now let's talk about 3 common game development problems that we have to deal with in map rendering. First off, aliasing. You might have noticed maps have a lot of lines. They're mostly lines, really, and a bunch of text. Now, both of these are very susceptible to the phenomena called aliasing. There are many different techniques to deal with that, some better than others, but the truth is, when your games run slow, the first thing you turn off is anti-aliasing. And so, since we are heavily bound by performance, we couldn't opt for the latest and greatest. We had to settle for one known as FXAA. Now, a property of that technique is that it makes text blurry. Please disregard the lines here. Half of that is that FXAA is not very good, and half is that I had to upscale the images to show the text. On your left-hand side, there is a text with FXAA applied. On the other screenshot, text with no FXAA. The rest of the images look the same. So we had to find a way to apply FXAA to the rest of the map and not the text. Now, the text could be put in any place in the stack of layers, so we couldn't just draw it last after applying FXAA. And the procedure that we figured out for that is when rendering symbols is a common name for text and icons, we also generate a texture which we then use as a mask in the post-processing step. When we apply FXAA, we sample that mask, and based on that decide whether to apply it to this fragment or not. That's how we managed to apply FXAA to everything else except for icons and text. Another challenge. This might seem simple, showing things that are obscured by other things, something that we call anti-occlusion. In the demo that Rock showed before, you might have noticed the buildings were going see-through, kind of popping in and out. This might seem like the obvious solution, but it didn't quite fit our needs. We needed to show only the most important bits, the most relevant elements for navigation through buildings. And so the way we approach this is, for each of those elements that needs to be visible through buildings, we added a dedicated layer that uses the same data, but shows a simplified version. This is how it appears as if the elements drawn on top of buildings are still behind them. And this is the process that we use to achieve that. When rendering, when filling the stencil buffer, at first we fill it with some predefined value. Then when rendering buildings, we write a different predefined value to the stencil buffer. And then when rendering the regular layers, we do the z-test as normal and check the stencil buffer. If the value is different than the one written when rendering buildings, we draw the regular version. So we only draw the ones that are outside of the buildings. When rendering the anti-occlusion layers, we skip the z-test. We want them to be rendered on top. They will still appear as if they were in the 3D space behind the buildings. So we skip the z-test and do a different stencil check. If the value is equal to the one written when rendering buildings, we render those simplified versions. And the last problem that I wanted to present, though it is not really a technique that we used, but rather how Unity helped us to use our existing technology to solve a problem in the new Unity product. Rendering text. This is one of the more complex tasks, and there are built-in solutions to do that, but again, we need performance. And so we couldn't use the built-in solutions. We had to look for something else. Turns out, running your C++ code in Unity is next to trivial. All it took was separating the bits that we needed from our existing code base, from our old in-house renderer, wrapping it in interfaces that were adjusted to our architecture in the Unity plugin, create a layer of bindings like what you see here, and we could use our old solution to render text in Unity in high quality. And that would be it for the technical part. But now let's hear a little bit about the UX from Arnaud. Over to you.
Thank you, Piotr. I'm going to switch sides, actually. Hi, I'm Arnaud. I work on the UX team with these lovely folks. So we're going to dive right in. So before we get into the cool Unity stuff, I'm not going to give a history of cartography. I'm not qualified to do it anyways. But at the top, anyone who's used a map in the last 500 years or so is going to be probably looking at a Mercator projection. That's Mr. Mercator. And then on the bottom, of course, is Luigi. And so we're basically between these two worlds. I meant Mario. That was a joke. It's a Friday kind of a, you know. You could laugh. So the thing to remember is that we're dealing with cartography, which is hundreds of years old, but we're applying gaming and entertainment to it. But we're still kind of maintaining the integrity of the data, right? We don't want to compromise the data. Rock was showing earlier the data streaming in and saying it's real, and it's absolutely still true. And the image on the left and right is the same area. It's basically the same data, but we're applying some of these gaming techniques. So we're bringing that into the map. Of course, maps have always had, those elements of different levels of detail, like we were talking about earlier. But as you get down to those lower zoom levels, we could actually start representing the real place rather than just having this abstract reference. It also allows you to make some dynamic, immersive kind of experiences. So what have we started doing? So leveraging Unity, the sort of low-hanging fruit, let's say, for gaming, lighting and atmosphere and fog and all of these things may be kind of obvious for games. It's kind of not that dramatic for games. But for maps, it's fairly dramatic. We're able to, again, not compromise the data. We're able to give basically a new life to the map while still giving the same functionality that people are used to in a map, right? We don't want to just shove the 3D in somebody's face and say, look, it's awesome. We want to be able to maintain all of the things that people are used to while still giving a more modern look and feel. Generations are growing up with games. They're expecting more out of the digital experience. And then automotive companies also want to kind of completely brand the experience. They don't just want a style. They want a brand and experience. So speaking on that, the way we're introducing it now is, again, in a subtle way. We don't want to shove the 3D in people's faces. This is an example from our Amigo Alpha app, which is a limited release at the moment. But on the left and right is exactly the same data, again, like I was mentioning earlier, but we're able to add a bit of a sense of place. You're able to actually get an idea of the layout of the city. We have these landmarks, which I'll talk about in a second. But again, the same data on the left and right could look very, very different. But as I mentioned before, we want it to feel familiar. You don't want to, again, force people to immerse themselves in the 3D so that you use all the same functionality as you had before. So this is a driving and navigation app. And what are we doing? So the low-hanging fruit I was mentioning earlier. So there's materials that we're leveraging, of course, separating out these different types of map data to say this is a road, this is a park, this is so on and so forth. And we give that sort of more premium kind of look and feel, right? When you get into a nice premium vehicle, the automotive brands want that to basically be expressed all the way down to the digital scale, all the way down to the map. So we could use these techniques and just add these kind of low-hanging fruit elements to kind of give it a new life, right? So on the left, which you saw earlier, we're kind of saying, let's make it a bit more tactile. Let's make it actually feel like water. And we could describe these different surfaces, if it's a desert or if it's a park or if it's a national park. And then a little bloom goes a long way, right? We could add a little bit of emphasis to high severity traffic incidents. And then the atmospherics on the right, which we saw earlier, which again, brings that sense of place. So when you zoom in, you can actually get an idea of what the cities are actually like. But with that, we also want to be able to focus on a specific task. So Rock mentioned earlier about having a driving versus an exploration kind of view. This is an example of how we're applying the customization that Unity affords us into this experience. So on the left, it's about kind of focusing on, again, the layout of the city. But if I'm driving, I want to see the surrounding road network. And what we're not doing, as Piotr mentioned, is having invisible buildings, because then you would be seeing a lot of that extra noise in the back, which you don't want to be seeing, a lot of high-frequency noise. We're not showing the roads all the way into the distance because I just need the ones that are just around me. I need to have that sort of situational awareness. a couple of different examples of that. So on the left, again, the same two styles. I can see the traffic incidents a little bit. I can see the road network a bit more. And this is a way to, if I have a route, okay, I could see the landmarks, but they're a little bit down-tuned. I could focus on the task at hand. Same thing in a night mode, where I could imply a sense of nighttime to the landmarks using a custom shader, which I'll talk about in a second. But then I could customize it and down-tune it again to keep the task focused. So landmarks, quick note on that. So TomTom has about the 20,000 landmarks. So they're basically these important structures. Could be a building, could be a statue, could be a fountain, all around the world. And the number is continually growing. But it was a spec that was done years ago. It's sort of low spec, right? It's 500 triangles, a single diffuse map, varying degrees of quality, let's say. And we're reworking the spec now to sort of modernize it. But we have 20,000 of these. We're not just going to throw them away. They're actually quite, they're quite useful, and they really give a sense of the character. So on the top, you've got Las Vegas, which we lit up in a way to kind of imply that sort of nighttime look. And then these different areas where we're applying this custom shader, which I'll talk about in a second. But basically, low-spec landmarks, but we're able to give them a completely new life in this new Unity environment. So the custom shader we have basically uses techniques like color per vertex, which is, again, not a new thing in games, pretty new for maps. And so we're able to give a completely kind of different look and feel to that low-spec landmark, and we could rebrand it, we could modify it to either fit the rest of the style or have them stand out, right? So here on the right, down-tuning it to see the road network. And if I didn't do anything, it would just be like this, standing out, but I want to have sort of a nighttime feel. And what's nice is that we're using, again, the same data, but then leveraging the Unity shaders to kind of, again, give a bit more flexibility to that. So how do you customize all this? Unity, yes, but also no. So TomTom has a web application. I mentioned earlier, cartography, map design, goes back hundreds of years. All of those cartographic principles, the concept of zoom levels, what do you show when, what kind of detail do you have the tiles at the different zoom levels? We have an application where you pick a template that's defined by our map design team, and you get started. You lay down the foundation of the map. So you don't just jump into Unity. You need to have a base map first before you even enter Unity. But this is sort of a what you see is what you get tool. And you could define all the different layers that are coming with the map. And then the finishing stuff is what you do in Unity. So let's say I'm in the tool, and I've got a style that I like, and I want to start seeing it in Unity. So we have this connection where you could copy the style URL, load it into the demo app. In this case, I'm doing it in the Unity editor, but we have a standalone Unity demo app where you could have this on a tablet, completely separate. And now you're kind of feeding that style into Unity so that you could still make changes to those foundational sort of cartographic layers underneath, and then see the Unity rendering on top. And what we've just added is, earlier I was using the editor to change the lighting, to change the fog. We've actually then exposed some of those parameters we just started in the web-based editor so that you could preview those Unity-specific properties. You're not going to see them on the left because it's the web map, but on the right, you could already kind of get a feel of what it's going to look like in Unity because you're in Unity. And so what's nice is that the customer doesn't have to have a Unity editor. They use the Unity app, and they could preview what it's going to look like. We could run scenarios in our demo app. We could create routes, adjust the camera for the navigation. Don't have time to go into the many features of the demo app, but there's quite a lot you can do. And while you're running those scenarios, you could continue updating the map style, right? So that sort of loop of being able to adjust things on the fly, while previewing the end experience is really a new thing for maps, especially for automotive. The other thing, this is a sort of an extra one, is we could sync the camera between the two using WebSockets. So we could have a live sort of view, and then again, I could tune the Unity specifics in the editor. In this case, I'm editing the landmarks, but I could have the map view on the left and right kind of sync together. And then, of course, this is a Tron style, so you have to have some kind of post effects. But everything that's happening underneath in this base style editor, I see the results again immediately in Unity, which is a great way to sort of, again, speed up that turnaround time. So what does it mean? it means we could take those styles for a spin. So when you have an automotive customer, you can't just look at the style in basically standalone in the editor or on your nice Retina display. So somebody's going to be driving with this. So it's really important to take it out on the road, and so that's what we do. Of course, I'm having to blur out the very thing I'm talking about here in the center images, because those are customer styles, but hopefully if we're invited next year to Unite, we can actually show those customer cases. But basically the workflow I was showing earlier is what the customers are using now. So you could even in the car, if you have your laptop and you're connected to a mobile network, you could update while we're driving. So we were updating the camera position to kind of get the right look and feel, the right zoom level, the right tilt. And then on the Unity side, we're in Unity, so we could overlay whatever we want, right? So the UI designers, they're working in Figma, they're working in these UI tools. We could extract a PNG and just overlay it. Because the crucial thing, like I mentioned earlier, is making sure that the map and the UI and the vehicle, it's all one experience rather than just something that's put on top. So it's a great way to sort of preview that end experience. And yeah, and that's currently the process we're going through with the OEMs. What I'm not mentioning is the target hardware, the target displays. Obviously, the cars, they're not shipping with a tablet. They have a cluster display here. They have a center stack display, various shapes and sizes, various resolutions and luminance. And so we're going through all that now. So that's something for a follow-up study of how we actually integrate it into the real car. But that cycle of being able to take, basically a concept, throwing it into a base map style in MapMaker, bringing it into Unity just like this is really a nice loop and just hasn't existed before for automotive. And before I wrap it up with the other things, there's other topics that we're exploring. I think they mentioned it a bit earlier, but the ability to leverage Unity, we're able to prototype in the production environment, right? So everything that we were showing before is real. It's also a nice thing is that typically you see concepts and early mock-ups and and this is basically real. So we're in the same environment in the production code, but we're able to leverage these different types of data sources, explore and discover kind of different ways of how the features might be handled. 3D terrain is obviously a big topic, but we could also, like the landmarks, we could restyle it. We don't have to be just stuck with whatever a satellite image is. We could imply different seasons and things like that. We could have tourist maps if we just scale up those landmarks. You could blend satellites with the vector map so that it isn't about switching to satellite and back. You could sort of blend those two together. There's some data consumption implications with that I won't get into, of course, but it's nice to be able to explore those things. And before handing it back to Rock, our marketing team is also leveraging this plugin. So it's kind of nice to have a marketing team who has no experience or background in Unity or these tools. We did a little onboarding, a little training, and now they're using that plugin and the Unity recorder to capture some high-res footage and then comping things together. And so it's nice when a marketing team uses the real thing to market things, which is not always the case. And then we have the concepts team. So this is a team that's unrestricted to our plugin, and so they're looking a bit further ahead, right? They're doing early concepts, vision work. They're using a simulator to test things out, but they're completely, not worried too much about the production aspect. That's sort of our part, I suppose. But it's another team at TomTom that's using Unity, but for these really advanced sort of things. And so that flow from going to early exploration to prototype to production, all within that same Unity environment is still something that we're heavily leveraging at TomTom. And back to Rock.
Thanks. And yeah, that kind of brings us to the whole circle, right? We have a product today that, as Arnaud mentioned, a lot of what basically everything you've been seeing except for the last slide is real, including this, what's behind me. This is the real product that we have running today. It's going to be in shipping cars next year sometime with multiple major OEMs. We have it in our mobile applications today for the alpha release. It's going to go to beta as well, probably sometime early next year. So all in all, it's gotten to the point where, yeah, we went from a concept to a complete product in a relatively short time frame, achieving the results around our pillars that we were really looking forward to. Generally a big success story, and thanks to Unity for enabling a lot of this, because it's not been all just technology. We also work closely with their support teams that Henning mentioned, obviously the Unity community out there and everything else. So, in summary, remember it all started with a demo, as I mentioned, but I couldn't just leave it here because this is where we are today, but we also want to look into the future. And of course, I have my product managers here that are already giving me like scared looks, like I'm gonna leak the roadmap. No, I wouldn't do that to them. But I will do the next best thing, right? I'll talk to my friend ChatGPT to kind of show me what we could achieve with a future product. Let's see. Oh, hold on. Let me try this again. Sometimes you have to be a little careful with what you ask from them, but all right, we got something. So, in themes of where we are today, I try to be inspired a little bit with the beautiful Barcelona, but of course, this is an example of course, what AI imagines a next generation of map visualization with slightly more sophisticated data sets might look like. But now you're all gonna say, but come on, this is AI gen, it's just faking things, right? So, okay, fair. But I mean, we are at the Unity event, we have lots of Unity experts here, so let's ask one of them, can we do this with Unity, right? So let's ask Henning, because he's right there in the audience. So Henning, tell me, can we do this in Unity? Well, Henning's on board, so clearly it's possible. But yeah, that brings us to the close. Thanks.